Hi and welcome back to Byte Forever. This video we're going to have another look at the ZXDB program, which is a debugger for ZX81. It was published by Bugbyte in 1982, and what we'll actually do is use ZXDB to have a look at its own code, which I thought would be quite cool. So working here, we've got the ZX expand attached down there, and so I'm loading all this off SD card. So it's just the standard load and save commands at this point. So what we can do is list it. So although you can't actually see all of the code, that's just the first page. Runs out of space. Even if you do scroll, it doesn't actually. Well, I suppose could you do list scroll? That's probably not done that before. No, I don't think you can. Anyway, yeah, just trust me that that's the first page of code, as it is in a basic program, encoded in a rem statement. So it's all assembly code, but it's encoded as tokens in a rem statement, which is fairly standard. List 10. So the next bit. The code actually starts running at 16640. That's the address. That's the command that runs, executes the ZXDB. And then this is sort of basic code which would execute the ZXAS assembler if you had that. What I've noticed is that when you run it the first time, it executes, then drops through to this and goes into sort of fast mode. Seeing as we're not actually running ZXAS, we can get rid of these lines just by typing in the line number. That deletes the line in ZX basic. So just get rid of all these. Hear the keyboard clicking there. This is like a micro switch keyboard, if I could say that properly. And it's just a lot better. There is a little bit of feedback, kind of like a normal modern keyboard. Yeah, so it replaces the calculator style membrane keyboard. So let's just run that. So expect, yeah, it runs, it drops through the first time. If you run it the second time, it does the same thing. Would you believe? Why is that? Let's go fast. Oh, I think it's because it's not in fast mode, which is what was set before. Let's just try that. Run. That's more like it. Yeah, so that's the quirk of this program. Because I'll delete the last few lines of the basic program. When it ran the assembly code, if it's not in fast mode, there must just be some condition there. It just drops straight out of there. And actually, that's probably the reason you have to normally run it twice anyway. Because the first time you run it, it goes into fast mode. So that's quite good. I've actually learned something there. So there's a few things we can do. We could, in the debugger, so the commands, the main command, V, would, or should, this isn't actually working properly. Okay, so it doesn't, so normally you get the asterisk prompt, type a command like V to view memory in hex, and then it would put up an equal sign, and then you type in the address. But because I've deleted the lines in the basic code, it's not actually running properly, so it's just dropping back to another prompt. So I think what we're going to have to do is reset. So it's actually ZXpand comes with a reset button as well, which is quite good. Load ZXDB. Alright, so if just list that, confirm it's loaded. we'll see the difference actually now. It's just doing exactly what we did before. And here it's kind of dropped into that bit of basic at the end. It's asking for an address effectively if you were going to assemble to, use the ZXAS assembler. So just run it again. I'm almost 100% sure that this will just run the debugger and it'll just work normally. So I think that has actually worked. So there you see you get the equal sign and it's waiting for a prompt to enter a number in hexadecimal. And with the V command, that's the view memory. So it just prints the next 8 bytes after the address that you put in. The other command, so if you did once you've started printing memory using the V command, if you press new line, it'll just keep printing out the next one. So until you press Q, if you were to do A0, so to print address 0 using the A command, that'll do it in just the character output. So it just kind of prints characters then. It's not quite as useful. Just quit out that. Another command is D for disassemble. So let's just disassemble 0. So right at the bottom of memory there. And this is actually when you start, or when you power on a Sinclair ZX81, this is the bit of code that runs. Just because that's what the Z80 CPU starts at address 0. And if you compare this to, well, first if you compare this bit of code to like the ROM disassembly, this isn't actually what you'll see in there. That's because we've got a ZXpand connected. So it's kind of got its own ROM, which is subtly different. I mean, it's kind of the same because most of the programs work, exactly the same with ZXpand, as you'd expect. Also, notice that this isn't a Zilog Z80 mnemonic, assembly mnemonic, because this particular program, it has quite a few actually, mnemonics prints out differently. So LHLD is equivalent, if I just look this up, it's equivalent to LDHL, comma, and then bracket and an address, so like an indirect address loads into register HL. Similarly, SHLD is the opposite way around, so that's LD bracket address, comma, HL, so that's loading the HL register into an indirect memory location from that address. Oh, should I say it loads the value of HL into whatever that address points to. It's a bit like a pointer dereference in C. So yeah, so we're actually looking at start a ROM there, so you can carry on doing that. Various things in the ZX81 ROM. Obviously, no comments because this is just what is in memory. Now, if you were quick to notice when I listed the basic program, you could actually see that this program, this debugger, it's executed from address 16640. So it was the print USR 16640, which causes this assembly code this machine code to run. And that is actually, so we can look at that. We can look at the code that this causes to run, or at ZXDB. So if we disassemble in hex 16640 will be 4100. So you can actually notice the flash. That's because ZX81 is in it's in fast mode, which means that whenever you interact with the keyboard or whenever the CPU is busy, it's not redrawing the screen. So that's where you get a flash or a kind of a bar while it redraws it. So there you see, this is actually what the debugger code looks like. We're running this code now, and this is actually what we see. So some of the things, there's some initialization code. call some subroutines. LDA17, that's actually the hex code for asterisk in the character set for this computer. So you can see it's loading A with that, and then it's actually, I think these subroutines are basically to print out that character, because that's what you see as the prompt. You can see up there, that was what we had. And it comes down here. I think this is basically reading the input that you've typed in. And you can see again, the debugger, the disassembly is actually printing that character, which 27 is B. That's one of the commands. It's comparing the accumulator with 27 if it's 0. In other words, if you typed in B, the letter B, then it jumps to that subroutine. D, disassembly, that's what we're actually in now. So if you type to D, it'll do a JP0, which after it's compared the accumulator 29. If the results was the accumulator stood 29, effectively JP0 subtracts accumulator from itself, or sorry, subtracts whatever you're comparing from the accumulator. And sorry, I got that wrong actually. The compare instruction subtracts that value from the accumulator, and then the result is stored in the flags, and if two numbers are equal, then this will return effectively true, and it'll trigger the jump. So what we could do, we could look at that code. So we can have to quit first, or press Q to go back to the prompt, and then we want to disassemble again. And now we're doing it at 44E2. So again, it calls a few subroutines, and eventually we won't get to a return, a ret instruction, because we didn't call this, we actually jumped here. So if you can see, it's actually jumping back to the start once it's detected that the key's been pressed, which is this bit of code, and that's similar to the other bit we looked at. It'll jump back to the start of the debugger. So you can see this is the bit of code that is printing out the memory locations and doing all the disassembly. And this will be interpreting like this is sort of stepping through the memory as well. So the inc HL, you see every time you press enter, increments HL and then goes back to the start. So yeah, that's just a little look at the ZXDB program. One thing you can actually do is you can execute the code. I think if you type, oh no, that's not right. So go Q, and if you type G and then memory address, I've not actually tried this. We'll try and run the debugger itself from within itself. Now this will probably just crash, but oh no, it didn't actually do anything. So it's a really quick look at that. It's quite a powerful program, I think. It does have a few problems like that initial time that you run it, and I've not, because I'm running ZXpand, I think because the ROM's different, I've not been able to load ZXAS, load or assemble some code, and then load the debugger and actually debug the code, single step through it. But yeah, it's fairly good program. I might try and find out why it has a few of those features that don't quite work, at least for my ROM. That'll be probably a future video. Okay, well, thanks for watching, and bye for now.